Now we're going to work on some examples from the Day 5 assignment, which deals with inverses of functions. In this first example, the tables show a function and its inverse, and they give us the function, but they want us to drag and drop to represent the inverse of the function. So since the only difference between a function and its inverse is that you switch the x's and the y's, if on this first set of points we have a domain value of 16 and a range value of 18, and we flip-flop them, the domain becomes the 18, and then the range becomes the 16. They did the next row for me, so with the 15 goes with the 60. They did the next row for me, and then on the last one, the 14 goes with the 32. Now, at the end, they ask if this new inverse is a function. What we want to make sure is that for every one value in the domain, that there is a unique value in the range, that no value is repeated. And since we don't see that, we would say that this is a function, and there's only one output, one unique output for every input. On this next one, they give us a set of ordered pairs, and they ask us for the inverse. So all we're going to do is switch the x's and the y's. Don't change the signs, just change x's and the y's. So instead of -3, -2, -2, -3. On the next one, -4, -2. Then -2, 0. Then 0, 2. And then 1 and 2. Okay, so that's correct. Now they want us to plot these new points. So let's go one by one. -2, -3. So that's going to be 2 to the left and 3 down, which is right around there. -4, -2, which is going to be 4 to the left and 2 down. -2, 0, which is 2 to the left. 0, 2, which is 2 up. And 1, 2, which is 1 to the right and 2 up. And this is also correct. Here they want us to find the inverse of this function that they've given us. So the way we find an inverse is to switch the x and the y. So we would start off by saying, instead of y equals 3x minus 8, x equals 3y minus 8, but then we have to solve for y. So plus 8 on both sides. X and 8 are not like terms. So we would say that x plus 8 is equal to 3y. Divide both sides by 3. So x plus 8 over 3 equals y. They've already written this for us in function notation, so I don't have to write a y equals. I would just write fraction bar x plus 8 over 3. And that's correct. Last example. Here, it looks like they want to find the inverse and then use a composition to verify that the functions are inverses, and then graph the function and its inverse. Okay, so first let's find the function. Instead of y equals x equals 5 over 8 x minus 5. Sorry, there should be a y here. 5 over 8 y minus 5. So we'll go plus 5 plus 5. These 5's cancel. So x plus 5 equals 5 over 8 y. Now the way you cancel out by multiplying by a fraction is to multiply by a reciprocal. So times 8 over 5 times 8 over 5. So y equals 8 over 5x. The 5's cancel, so you get plus 8. So that's what I'll write in. 8 over 5 x plus 8. Now here, this is a composition. It says that the inverse composed with the function is either going to be equal to or not equal to the original. So let's compose both of these. If I were to first plug in the inverse into the actual function, then I would have 5 over 8. Instead of x, I would write 8 over 5 x plus 8 and then minus 5. The reciprocals would cancel out. Then 5 over 8. Here, those reciprocals cancel out, and then 5 over 8 times 8 would give me 5. So I would have x plus 5 minus 5. Now the 5s would cancel, so that indeed would leave me x. If I go the other way around and now plug the function into its inverse, I would now have 8 over 5. Instead of x, I would write 5 over 8 x minus 5. And then at the end, that would be a plus 8. The reciprocals cancel again. The 5s would also cancel, so I would get x minus 8 plus 8, which would just give me x also. So it looks that in each instance, composing the function with its inverse just gives you the original. Now let's take care of the graph. First, our function, which is 5 over 8x minus 5. So we are crossing the y-axis at negative 5, and the slope is 5 over 8. And it's a positive slope. Minus 5. So go up 5. Right around there. And it drew the rest of the line for me. Then the inverse crosses at positive 8. And there the slope is 8 over 5. And you know what? I just realized I went the wrong way. I got to do the function again. I should have gone this way with it. It was a positive slope. Alright, so let's do the same thing now with the inverse. Let's cross at positive 8, and my slope is 8 over 5, also positive. So that'll bring me around here. Down 8, left 5. Okay. And what we should be seeing is that all three meet at a point. I might have to redo this. I don't know if it's going to let it slide, but let's see. There you go. I let it go.